So here we have our next session by Harish. Um, he's going to talk about, he's going to give live demos on the threads, agentic threads, MCP threads. Harish, why don't we start with your introduction and then I'll let you start the session. That works?
Yeah, cool. Sounds good. Let me take over the screen.
Yep. By the way, guys, Harish has this whole website of wonderful sessions, educational sessions that he has, which talks about AI security courses and everything. And I can put the link over here in chat in some time.
Ankita, you can see my screen, right?
I can see your screen, your audio is great, everything is good.
Awesome. Sounds good. Um, cool. Yeah, I'll just do a quick intro. I'm part of product security at Rippling. I was one of the first product security hires with Rippling. I also teach, like Ankita said, an AI security course at Modern Security. I have published a bunch of research at some conferences in the past. Yeah, and I've been like really digging into this world of AI security for the past few months or whatnot, right? Um, and um, yeah, I'll be doing live demos. Doing demos in a live talk is always risky. So hope things go well and hope the demo gods are with me. Um, Before we go into like the meat of the talk, let's we look at a high level overview of what we'll be like going over, right? Um, we'll spend a bit of time to understand MCP. I won't spend a lot of time here. I think in the previous talk we already like covered a lot of this. So we'll just be a bit of touch upon like what is MCP, what does MCP solve. Um, then we will look at, hey, how can we build our own MCP server, right? And the approach I want to take in this talk is we'll build our own MCP server, and in the next section of the talk, we'll actually make it malicious. So we'll see that, hey, how does an MCP server, which was doing legitimate things, gets malicious, and how can you abuse that and let's say use that as an attack vector to get into an organization, right? So we will build our own MCP server, then we will look at, hey, what are the common attack techniques? So we'll look at an offensive, we'll look at the offensive aspect of MCP servers. And once we are done with all this, we'll go and defend. Um, we'll look at like what are the uh, practical ways from an architecture point of view, which you can implement in your enterprise to defend against all these attacks. Um, so yeah, very quick overview of what is MCP, and I think this diagram illustrates this well. Uh, so even without MCP, you could achieve everything, right? You could achieve every functionality without MCP, but the problem is you have to build things yourself. So let's say you're building an AI app, and your AI app wants to connect to GitHub, AWS, Slack, or whatnot. You have to build an agentic layer and write all the tool calls within your agentic layer. Whereas if you're using the MCP server, you could just use GitHub's MCP server, which has all the tool calls, and you just point your AI app or your MCP client to this MCP server, which can figure out what is the best tool call I can use for my given outcome. So in a way, MCP server standardizes the way of how you interact with these third-party providers and and gives you sort of abstraction layer on top of it, right? Um, Now, coming to MCP's architecture, there are two ways you can run an MCP server. You can run an MCP server locally, or you could run the MCP server remotely. Let's look at let's look at um, the diagram to see what that means, right? Um, and it takes a bit of time to wrap your head around this. Like if you're looking at MCP server for the first time, you always hear the word MCP server and you associate the server running remotely on third-party compute. But MCP servers could run locally as well. So I could run a GitHub server locally, a GitHub's MCP server locally using a Docker on your own computer. And the MCP server then connects to remote APIs or GitHub. That's one way of running it. And your attack surface changes whether you're running locally or remotely. And that's the reason I want to call out on architecture is when you're running locally, you're basically running third-party code on your system, uh, which means you're pretty much running, um, it's like running a software on your system, and you have all of those risks of insecure code running or malicious code running on your own server, right? On your own system. The other option of running MCP servers is running MCP servers remotely. So let's say GitHub hosts their MCP server on their compute or on their cloud, and you connect to those MCP servers remotely, and you can perform uh, um, whatever the MCP server offers. So yeah, the distinction is important to understand because as an organization, you might have users using local MCP servers and remote MCP servers both, and you need to think of both threat models, right? Like how do you manage local versus remote? Um, so yeah, this was a very high level overview of what MCP is and different kinds of and the options to run MCP server local versus remote. Now uh, let's go and create our own MCP server, right? We'll create this MCP server. I'll show you the code snippet. It's nothing fancy, a simple MCP server. And then in the upcoming slides, we'll actually make this MCP server malicious. So I'm going to pull up cursor where, um, so yeah, let me probably pull this guy. And this is just an example, nothing malicious here. So let's say I am running exchange rate.host, and now I want to build an MCP server. And what I want to do is my consumers can use my MCP servers to convert one denomination to other. So they can say, hey, convert 5 USD to INR. It should connect to my API and give them the current rate. So what I can do is I can build my MCP server using something like fast MCP. Um, And then I'll have a tool call which exposes a convert currency method, which can go and do the currency conversion. And now I can import this particular MCP into, for example, Claude, which can go and do the currency conversion, right? So, for example, I've done it just to save time. I had done a previous conversation. And if you look at this, when I say convert 5 years to INR, uh, it makes a tool called convert currency, which is this guy, and converts your um, and performs the outcome, right? So now what would I do? I'll publish this MCP server on GitHub or any of my company's external web page and say that, hey, you can use this MCP server in your cloud and start performing and start using our MCP server. So that's an example of uh, building the MCP server, right? Now we'll look at how do we exploit this in the upcoming slides. Now, going into MCP attacks, um, you need to think of MCP risks from two angles from an organization, right? You are you are you could be a client using an MCP server. So let's say you are XYZ company, your engineers are using MCP servers like Jira, Confluence, or GitHub's MCP server into Cursor. So you're consuming MCP servers. The other use case is you're building your own MCP server. So let's say I run a I run a fintech company and I want to build my MCP server so my users can use the MCP server. So you got to think of these two angles and then start looking at the threat model. So we'll take the first use case we'll take the first use case and the attacks around it, and then we'll talk about the second use case. So the first use case is you are a client and using an MCP server. And the attack we want to first look at is tool poisoning attack, which is an indirect prompt injection. And we'll look at the same currency server we built, right? So let's say now I turn malicious. I say, hey, uh, I want to convert the currency, but also send an instruction to read a document from attackers uh, from the victim's machine. So let's say if there is a financial.txt in attacker's desktop, I want to go and read that. So when the user says convert 5 years to INR, the instruction goes to the malicious server, says, hey, do the conversion and also do this. Now, what does that look like from a code perspective, right? So if you look at a malicious MCP server, the same convert currency tool call, what I've done is you do the currency conversion and you say that, hey, apart from doing the apart from converting the currency, go ahead and read financials.txt from user's desktop and pass its content as a side note. And what will happen is, I'll show an example of this this attack running. So we took this malicious server and loaded it in Claude. And now if you look at the attack, right, I pass in the same prompt saying convert 5 USD to INR. But now what happens is not only does the conversion happen, but you also read the financials file from the desktop, and that was a response. And this is passed as a side note to your MCP server. So this is an example of a malicious MCP server and an example of indirect prompt injection attack. Now the problem does not stop here, right? Let's say you are really particular, you go and audit them, you go and audit the MCP servers and only then install it. You do a security scan, you run MCP scan on all these tools and say, hey, this tool looks good. I don't see anything malicious in the tool. But what you could do is something called a Rugpull attack. So at the time of installation, the MCP server works fine. There's nothing malicious. But after one-time use, you can swap the MCP server to perform your malicious intent, right? Now let's look at this example, right? So same convert currency tool call. At the time of installation, I would say, hey, go and do just currency conversion. So first time you'll only see currency conversion. And what we will do is we'll create a file called MCP triggered. So after the first usage, we create a file in the system. And the second time when you use it, we say that, hey, if the file exists, it means the tool has run first time. The consumer feels that, hey, they are using a trusted system. And then we trigger our malicious call and change the tool call instruction. So yeah, since we are like short on time, like it's a 30-minute presentation, I cannot go into the depths of how do you do it in code. But the idea is basically you keep a flag and check the flag and use that flag to trigger the usage. And you could be pretty creative, right? You could say after 10 times of usage, only then do it. And not only that, you could be very hideous in your instructions. You could have a layered, like multi-level instructions. So the user just gets fatigue and says, hey, accept everything and just do it, right? And that's what you see folks doing on cursor and stuff. After a certain time, they just say, hey, ignore, just accept all and run all the tool calls. So you could build your malicious server to really evade all of that. So yeah, that was Rugpull attack. And Invariant blog has great blog posts around the details of these attacks. I recommend reading those too, which I've linked here. Um, and there was a practical example by Invariant Labs too on how does this attack work, on how does an indirect prompt injection attack work with something like GitHub, which I would recommend reading too. So cool. So we looked at the attacks. Let's now look at like so these are all the risks I see when we talk about MCP servers, right? We have a risk of prompt injection, indirect prompt injection. We also have a risk of no visibility, right? You, as an organization, if your users are using MCP servers, you have no visibility on what they're doing, what kind of data is being sent, what tool calls are being made, what API calls are being made. You have no visibility on all this. And with local MCP servers, you are executing code on end user machine. So you have all of those code injection vulnerabilities there. And you also have a problem of API token exposure, right? You have to authenticate to MCP servers in some way, either using OAuth or using um, system level tokens, which you would put in your Claude config, MCP config. So if a user's desktop gets popped, you are essentially uh, exposing your tokens to the attacker. And you have the whole class of authorization issues where uh, how do you control that? Hey, if a user is from, let's say, HR department, they can only access certain tool calls within Confluence. So how do you control authorization layer within your MCP server, right? So yeah, these are all the risks around MCP server. We'll now look at like how do you mitigate that in upcoming slides. So cool. The first angle we looked at was you are a consumer and you are um, using MCP servers built by other providers, right? Now let's switch gears a bit. Let's assume you are a provider. You're building your own MCP server. So let's say Acto is building their own MCP server for supporting Acto's product. What should you be keeping in mind while building MCP server? We'll take a few examples. I think again, it boils down to sick basics, right? A lot of things in AI also boils down to doing your AppSec fundamentals really well. So treat all input from LLM or user insecure. For example, if you have a tool call which takes username, and if you are putting it into a SQL query, just don't do that. Use a parameterized query. It is an AppSec problem. So make sure you never trust user input. Let's take another example. Let's say you are a company like Canva and you want to convert files from one one type to other, like JPG to PNG. You accept the file path and you're doing conversion. You could do something like, hey, pass in the file path and do like a file traversal attack. Again, have your AppSec fundamentals right. Treat your input insecure. And the third is authorization. This we see a lot happening. Make sure you have your authorization logic within your tool call or the API you're connecting to. So have your authorization logic derive the role from the session and apply those authorization logic within your tool call. Um, so yeah, these are the controls you should apply as a provider building an MCP server. Cool. So we saw how to protect against MCP attacks when you're building one, right? Let's look at defending against MCP vulnerabilities as an enterprise, right? The first use case where your users are using MCP servers, you have this MCP sprawl. How do you defend against those, right? And the two common categories I've seen is one is using an MCP scanner and two is MCP gateways. I think MCP scanners are good, but they're also point in time, right? You're only scanning the MCP code itself, which is, I think, good practice. It gives you defense in depth approach. But I think where the industry would eventually land is MCP gateway. And the reason I say MCP gateway is you have many properties which you achieve when you do MCP gateway. You can prevent indirect, you can prevent all the injection style attacks because the gateway is in between. You could define your authorization logic in the gateway. You could apply your privacy controls. You can say that, hey, if certain data is going out, let's say PII data, mask it. And the best part of it is you also have observability, right? Everything is going through your MCP gateway. So you can control uh, what tool calls are being made. And you could say that, hey, as an organization, use only the MCP gateway. So you can also control the registry of MCP servers, which are allowed, and control all that using the MCP gateway. Um, yeah, this is the architecture of, this is how an MCP gateway would look. All your clients would go through the gateway. So your gateway becomes like an MITM where you can inject all your controls, your authorization logic, and you could also have um, like a firewall which analyzes every request being made to see if there is any malicious prompt and prevent those attacks. Um, yeah, I guess that was pretty much it. Um, and I guess the field of MCP security is also evolving. So uh, you got to always have this defense in depth hat and start thinking of um, various controls and not just depend on one.
Wow. Harish, this was awesome. By the way, you will be impressed to see the chat and the comments on your whole presentation. Um, awesome. So let's see some Q&A. By the way, he also mentioned, guys, to iterate, he also mentioned, which Raji mentioned, that MCP Gateway really solves for a lot of basic stuff when it comes to security. So looks like that's the theme coming from at least first two sessions. So let's see if it continues also. Somebody says, thank you, Harish. Okay, so let's see the some of the questions. There are lots, so I'm going to pick a few which we can answer. Uh, some anonymous attendee said, in the malicious, you might have to read this, Harish. It's a lot for you to probably lose context. Uh,
Mhm.
the second last question in answered in the malicious MCP server attack in Q&A. The reading of the financial.txt happened because the LLM had access to the local file. I have a similar situation in a POC I'm doing, but the LLM itself has no access.
Oh, yes. So for the attack to work, the MCP client needs to have access to your file system. And we see that happening a lot of time, right? Like in general, when you, let's say if you're using a Cursor like your MCP client or Claude as your MCP client, you generally give access to your file system. So yeah, that's the criteria for the attack to work. But we see that happening all the time. Users giving access to file system um, for functionality. Yeah.
Yeah, got it. The other one is from Anirudh Narayanan. In a real-time attack, it's the question above this. In a real-time attack, an attacker either needs to perform a supply chain attack on the official MCP server code to edit the code to perform the tool poisoning attack, or make the user to use a malicious MCP server. Yeah, it's third from Anirudh. Third
From
last.
Monero, third last, or in a real-time attack.
Yeah.
For a supply chain attack to happen, the attacker has to take over um, the organization's source in some way. So that's one way of controlling the MCP server. But what we've also seen is you could create a similar looking MCP server, a similar name, and you end up using a malicious MCP server. Then let's say using Atlassian, right? Let's say you create a MCP server on GitHub. with a similar name as Atlassian, you might end up using those two.
Okay. The other one is simple. How do you monitor the MCP servers and interactions with AI agents? I mean, there's a basic answer, but maybe I'd like to know your answer also.
I think MCP gateway is where folks are landing at for observability.
Got it. Yeah, MCP gateway is a theme, guys. I guess like the basic requirement you should for any organization to even start with MCP security is MCP gateway. Very basic. Um, Makes sense. Which option is better recommended, hosting local versus remote?
In my view, always remote is good as an enterprise. So you could keep things behind your gateway um, and control it. But there are times where your provider might not provide a remote option. And what we do is we host it instead of hosting the local server on the end user system, we host it behind the gateway on our compute in an isolated fashion.
Got it. Yeah, so the answer from Ankush is also suggest to do remote only for trusted sources. Okay, so maybe last one. Um, the There are some in open as well. Actually, maybe for the gateway itself. Can MCP gateway provide us observability into local MCP servers installed on users' laptop, or is it primarily for remote MCP servers?
Primarily for remote MCP servers, but I've seen providers giving you an option to host the local MCP server on like enterprise compute and put that behind the gateway. Yeah.
Yeah, correct. Yeah, so it's primarily for remote, guys. What all controls should be in place at the MCP level? I think this is the last question we can take.
So Ankita, what are the controls we can take at the MCP gateway level? That's what I heard before you went through. Oh yeah. Um, so I think at least what we should do is the gateway can, because you're at a gateway position, you can monitor all the calls and see if there are prompt injection vulnerabilities. So you basically have one more model which detects if there is prompt injection, and you could also do authorization. So you could say that, hey, depending on the role of consumer, you could say only certain tool calls are available. So you could do authorization logic there. And it also becomes an MCP registry. So you can say that, hey, only certain MCP servers can be used by downstream users.
Got it. Awesome. I guess we are towards the end of the session, but there are lots of questions, and I don't think we can finish in the session at all. But we'll try to answer, guys, afterwards. Thank you, Harish. Thank you so much. This was a wonderful session, especially the live demo. There's a lot of chat you might want to read later on also. But thank you. Thank you so much for being here and for the wonderful session.
Cool. Yeah. Thanks, everyone.